I want to talk about time travel next. And before we get to the specifics, I have a broader question. And just what is the purpose or utility of theorizing about time travel as a philosopher? Is your goal like to carve out a direction for actual engineers to begin working, or is it just fun, or are the thought experiments meant to tease out possible problems with how we conceive of time, or a mixture of this and other factors? Because it seems like it might just be like science fiction fun, basically.
Well, I think if I can start, I think if we just think about it as a topic in philosophy and in philosophy courses, I mean, so there's a kind of independent history in physics. I think about why people talk about closed time-like curves and time travel. But in just in philosophy, it is a great topic to sort of tease out many different sort of thoughts. The philosopher David Lewis used to teach a whole semester-long course on time travel because it would implicate all these issues with time, direction of time, free will, fatalism that we discussed earlier, personal identity. So it's a kind of great, it's a kind of wedge that you can tease out different sorts of views, different sorts of issues, and a whole range of different views. Topics. So I think it is good as a thought experiment. And then, in philosophy, I think most philosophers thought for conceptual reasons, time travel was impossible until there were papers by Paul Horwich and David Lewis in the early 70s that then I think convinced people that time travel was at least conceptually conceivable, not incoherent. And then, of course, coupled with relativity, general relativity allowing, or at least has solutions that accept or have time travel in them, then philosophers, really started to warm up to time travel. Does that seem right, Tim?
Yeah, I think everything you said is correct. Of course, the original target, which is, time travel is logically inconsistent. That was way too strong.
Especially that people are making those arguments when already there were things like the Gödel solution in general relativity, which, if it was mathematically consistent and physically consistent.
Yeah, exactly. And then
had to be consistent.
Clever science fiction writers writing all these clearly, logically coherent time travel stories. But that was way too strong. I mean, what we should ultimately care about is it metaphysically possible, right? Is it consistent with the very nature of time itself that this happened? That will come out differently depending on the account you give of the very time itself, right? On my account, it isn't, right? On some other people are trying to give accounts of time in which it is. So at least it's a good test case to see how these accounts come apart, right? To see what they're committed to and what they're not committed to. It's certainly, none of us are designing time machines, right? None of us are trying to help engineers actually create time travel.
That'd be a good side gig, consulting.
Yeah.
Now, Tim, I wonder what you think about, so I've been thinking, so Robinson, so general relativity allows some models of some solutions to Einstein's field equations. So if you think of these as of the possible worlds of the theory, it then allows for some where you have time travel. So famously, Kurt Gödel's solution, but there are many others which would allow for time travel. But then, I wonder whether, when we think about general relativity, what would be lost? So I'm thinking about this from a kind of Humean laws of nature sort of thing that I'm sympathetic to. If we just cut those out, so we just restricted our general relativity to well, this would be a technical thing, but just restrict it to, say, the globally hyperbolic solutions. So these are ones, well, wait, there's a step below globally hyperbolic where you get all of them have closed time, all of them have cosmic times and no closed time-like curves. But basically, these would be like the nice, well-behaved space-times. And what is really lost if we just cut out all those kind of bad boy space-times that have time travel, since we don't actually see it? So I wonder whether this is a kind of picture where that kind of Humean stuff ends up aligning with, your sort of fundamental direction of time picture, because I just don't see a need for these.
Well, yeah. And I think it's worthwhile pointing out, and again, Robinson, you should slow me down if what I'm about to say goes too quickly. But there's some things we've already mentioned. So a space-time is temporally orientable, as Craig said, if basically you can take all the light cones and divide them into two classes, the future ones and the past ones. And that as you move continuously through, the future ones just go into future ones, right? And so an example where you couldn't do this is sort of like a Mobius strip thing, where you would take this space-time and give it a half twist and glue it back together, so that if you, as it were, start here and future is this way, you go around and then that arrow is now pointing down. So that's not temporally orientable. Now, there are solutions to Einstein's field equation that are not temporally orientable. But physicists never take them seriously as representations of the way time could actually be. They just reject them, saying, look, that's not a realistic solution because it's not temporally orientable. I think that's perfectly reasonable. What they also tended to do was say the same thing about closed time-like curves or time travel. Yeah, there are solutions, and there are fancy solutions like girdles, and there are simpler solutions where you just roll the thing up. And many physicists just ruled them out and say those are unphysical solutions, right? They're mathematically well-defined, but they don't correspond to the way the physical world could be. Why? Because time doesn't go around in a circle. That's why. I think that's a perfectly reasonable thing to do. I mean, a lot of this is pushed by people who are so enamored of the mathematics that they think, oh, I've got all these solutions to the equations, I have to treat them all seriously. But you don't, and physicists never have. You would like a sharp criterion for separating the sheep from the goats, as it were. But in this case, we have a sharp criterion. So I agree with Craig. I don't think you would lose anything. You'd certainly lose none of the explanatory power of actual physics, because we don't have a single physical phenomenon that seems to require anything like time travel. So it's not like we need it, right?
Philosophers would lose a lot of fun, because a lot of these times are really fun, and part of me would die if we got rid of them all. But yeah, intellectually, it's very hard to defend them, I think. I mean, sometimes people say, well, maybe we might use them, or they'll point to some speculative theory that maybe might require them. And then, but then I think the thing to do is just to say, well, come back to me when that theory is really a good one and actually does require one.
Well, just a quick comment. Craig, you mentioned Paul Horwich a few minutes ago. He's definitely one of my favorite people in philosophy, Tim's colleague. We had a conversation on the podcast about realism, which is kind of funny because he doesn't like the term realism, and then he came to Stanford, and that was great. But I knew that he got his start in the philosophy of physics, but I didn't know he'd written about time travel. So that's good for me to know.
Also, he has, I wonder if I have it here in my office. I think it is the most beat up book I have is I was doing my dissertation on the direction of time, and he had he had a book, Asymmetries in Time, and I don't even think the book has a cover anymore. But it was so read and reread back in the early 90s. It's a really wonderful book.
Well, what I was going to ask next, though, after that quick comment was whether there is any compelling logical or metaphysical argumentation against the possibility of time travel that should preclude or even going farther into the physics and philosophy of it. But Tim, I mean, I had on the logical side something like the grandfather paradox in mind, but Tim, you mentioned that suggesting it's logically impossible is too strong, but that it is metaphysically incompatible with your view of time. So I guess I have two questions. Since the grandfather paradox is such a common topic and it hasn't come to the podcast yet, maybe we could talk a bit about it and why you think it's too strong or doesn't rule out time travel. And then on the other hand, I'm curious about why it's incompatible with your view of time.
Okay, so the incompatibility is pretty simple to state. I think that, as I say, by definition, causes precede their effects. And I think this earlier-later relation is transitive. So if A precedes B and B precedes C, then A precedes C. And I think that nothing that nothing precedes itself, right? So then there can't be loops, right? It means you have what we call an acyclic graph. If we put in the earlier arrow from every earlier event to every later event to it, that you'll get a graph, and it's got to be acyclic. And that rules out that kind of time travel with backward causation or circles of causation. Now, traditionally philosophers from forever thought that things can't cause themselves, right? That there's something a little screwy about saying that something caused itself, because you say, but wait, if it wasn't there already, how could it cause itself to come into existence without already being there? And if it's already there, then nothing needs to cause it to come into existence because it's already there. Things like that. I mean, those are, tricky little arguments. I don't think you can get literally a contradiction out of just the words, or the words plus the temporal structure. I can get a contradiction because I have a particular theory about the temporal structure, that it has it has transitivity in its, and it's nothing ever causes itself or nothing ever precedes itself. Then you can run consequences out of that. But people who disagree are just going to deny those assumptions, right? They're going to say, well, gee, I don't think it has to be transitive, or I think it's okay for something to cause itself. So these are not literally deriving P and not P, which would really be a logical problem, right? That it's logic. That doesn't happen because, as I say, there are just lots of nice, coherently written time travel stories in the science fiction literature, like All You Zombies, or, in the movie 12 Monkeys or whatever. There are many more crummy ones that are inconsistent and don't make any sense, where you go back and change the past, as they say, like in Back to the Future. That just doesn't make any sense because the past only happened once. You might be able to influence the past, but one thing you can't do is change it. But there are consistent ones, and the existence of consistent time travel stories shows you're not going to get into trouble with logic. The normal idea, as you know, is someone says, well, if I could travel to the past, then I could travel to the past and kill my grandfather. But if I killed my grandfather, then I would never have been born, and then I couldn't travel to the past. And so that's a contradiction. There's a bunch of literature in the literature of mathematical physics about, if you take a scenario like that and actually try to realize it using actual physics written down as equations, and if the equations have certain mathematical properties of continuity and so on, you can actually prove theorems, fixed point theorems, that show there will always be a solution. You'll never get into a case where you set up a situation that doesn't have a solution. It'll always have a solution. Sometimes it'll have more than one. I go into the past and try and shoot, well, let me just do the auto suicide one. It's easier. I go into the past to try and kill myself because I'm so miserable and I don't want to go through this, right? So, let me go back, a little earlier and kill myself. So I go back, I grab a gun, I go back, I shoot at my earlier self, but my arm vibrates, right? My aim isn't true. And I just nick my spine. And I nick my spine in exactly the spot that causes my arm to no longer be a reliable aiming mechanism. So that when I try and kill myself, the very thing. Now, the existence of such solutions, which don't violate the laws of physics anywhere, is proven by various fixed point theorems under certain statable conditions. And again, if you have a mathematical solution that's okay, it's illogically okay too. So often the grandfather paradox just makes assumptions which, if you try and make them into clean physical assertions, turn out not to be things you can really defend. So I don't think that's the right way to get rid of the problem.
I interviewed...
That went real quick, I know. I'm sorry.
No problem. I interviewed Avi Loeb, an astrophysicist at Harvard, and I don't know if this came up in the podcast or just when I was preparing, but he said, or I read, that he only likes science fiction movies that are compatible with physics as he knows it. And am I correct in hearing you, Tim, though, that you, even though you don't think that time travel is compatible with your views of physics and time in particular, you can still enjoy time travel movies like All You Zombies?
I enjoy a well-made, consistent... I mean, I don't like the ones that are logically inconsistent, right? Like Back to the Future. That annoys me. I like it when they put the effort to make them logically consistent. And I like if they kind of gesture at some physics that might be relevant in a coherent way. I mean, I appreciate the effort.
Yeah, 12 Monkeys is fantastic, I've always thought. And yeah, I have my students often write assignments on analyzing whether some time travel story in fiction is consistent or not. And I always tell them that they can't use Back to the Future, any of the movies, because it's just so ridiculously stupid that it's just they can't do it. But it is kind of interesting. Yeah, what I especially like about 12 Monkeys is that it's, a lot of the time travel stories that are consistent, if the protagonist had read a lot of philosophy of time travel, they would not behave the way they did. But 12 Monkeys is one of the exceptions to that, because they accept up front that they can't change the past, but they can still learn from it and influence it, and that which is really awesome about that movie.
And Craig, returning, we can always come back to movies, but time travel is compatible with the way that you view time, or it isn't?
Circling back, I think a kind of quick little checklist would be, I think Tim and I agree that time travel is logically possible. We probably disagree whether it's metaphysically possible. And then we are both heterodox in thinking that maybe maybe the arguments for it being physically possible are not as strong as commonly taken in the field. So I have no problem with metaphysically. I have no problem at all with it being metaphysically possible. But I think because it doesn't happen, and I read my physical possibility as best describing what's actually happening, that maybe then in that sense it physically couldn't happen.
And I know
but conceivably, no problem.
I know that
there is. I'll just mention for people who understand this comment. Craig said this before. His Humeanism about laws is coming into what he just said. And since I'm not a Humean about laws, this is where one of our disagreements would lie. But we don't need to go into that. But that's for people keeping score at home. That just happened.
Also, I would claim that not only am I Humean about laws, but I'm the most Humean about laws.
Well, I started off by asking whether or not you guys consulted with people trying to engineer time machines, though I didn't put it that way. But I wonder, as somebody who does think that time travel is at least conceivable, do you at all think about how it might be done, or if it's actually technologically conceivable. I'm thinking, I don't know what movie it is. One of you probably knows, or maybe it's in multiple movies where somebody like draws a figure on a piece of paper and then like closes it and then puts like a pencil
Yeah,
through it.
there is this literature on time machines as opposed to time travel, and I don't really know too much about it. But I know, sorry, I know it looks hard.
Well, it's
So you can
more than that, right? I mean,
remember Tipler had a thing where if you had a infinite cylinder, so if you aligned all these neutron stars in a kind of big cylinder and they're all rotating the same, then that would bring about those time-like curves.
I don't think that's technically right. I mean, there's this famous among the small group of people who do this paper called "Take a Ride on a Time Machine" by John Ehrman and Gordon Belloc. There may be somebody else on the paper, and they asked the following question. So there are these solutions to general relativity that have closed time-like curves, but they're just put in by hand, or put in. You put them in because you're asking, can I solve these equations? Do any of the solutions have this particular feature, right? But then you can ask the question, well, suppose I'm in a universe where up until now there are no time-like curves. Can I then do something, right? Go into a lab, build something, create something that would cause there to be closed time-like curves? And as I recall, the conclusion from their paper, which surveyed a lot of the physics literature and looked at some of the technical mathematical issues, was just no, at least not in general relativity, that you can't build a time machine in that sense. There could be, well, this would be a view that says there could be time travel, but if there is, there is. If there isn't, we can't do anything about it.
Yeah, I think there's a lot of very technical debate there. Yeah, I know, up the street, JB Manchak has, theorems, and then there's theorems the other way, and I don't know. But it doesn't look like it's something easily done.
One of the earliest, by the way, contributions of philosophers to this whole literature was, Craig mentioned that one of the solutions with closed time-like curves was produced by Gödel for Einstein's birthday present, oddly enough. But anyway, produced by Gödel. And so everybody knew there was this solution. But to go around in this circle, you actually couldn't just drift. You really needed to accelerate. Okay, you needed to have a rocket with an engine to push you around one of these circles. And David Maudlin actually did a calculation of how much fuel you would need to get in a rocket. If you happen to live in Gödel's universe, to get in a rocket and actually take a travel around one of these things. And he found that you'd need so much fuel that it would distort and destroy the entire solution because the gravitational mass of the rocket would mess everything up. So it actually turned out to be practically impossible. Even though there were time-like curves, it would be practically impossible for a person to go along them. It turns out time travel is possible, but it's just too expensive. If it's like $5 a gallon.
Well, I have
another thing to mention, Robinson, that often doesn't come up is that's a challenge for time travel is that is the direction of time, thermodynamics. I mean, so if you went back, how is this going to be compatible with the second law of thermodynamics, where you've got entropy increasing all the time? Is it gonna? Well, logically, you could imagine like putting the world on a cylinder, rolling things up, having a gas expand, and then around the cylinder come back. And so there's not a kind of logical contradiction between the two, but it's not obvious how you're going to, send a macroscopic object like you, Robinson, back in time and have that be compatible with the second law of
Well, I have one last time travel question before we finish, and I think it should be pretty quick, but my favorite time travel movie, when I think about it, is probably not a good movie at all. It's just time and place that I saw it when I was a kid. But it's H.G. Wells' time machine with Guy Pearce, and in that movie, he does go to the past to try to prevent his girlfriend or fiance from dying. But the crux of the movie is that he gets in a time machine and goes to the future. But we haven't talked about time travel to the future at all. Is there a reason that we haven't? Is that more?
We're doing it all the time. It's not interesting. Right now, aren't we all? We're all older than we started this thing. We've been traveling through time during this conversation into the future. Now, you might want to get further into the future. I would suggest just cryogenesis. I mean, I would just, figure out how to freeze yourself if you really want to see the distant future. Maybe you can freeze yourself and thaw yourself out. That seems practically much easier to do than anything really fancy. But time travel to the future is trivial. It happens all the time. So what's there to talk about?
Yeah, if you think of like the twin paradox, the twin who leaves comes back and, they're younger. Just go a little faster, go a little further, and you get...
Well, they're younger than the twin, but they're older than when they left.
Yeah.
Both twins are still aging toward the future.
Yeah. Well, they're...
his only advantage is he can, make fun of his twin. But
Well, I mean, I don't want to push this because we have to finish, but there is a sense of time travel to the future that isn't as trivial as you're making it sound. Like, I mean, if I want to jump 2,000 years into the future and grab some future weapon or something, and then, I mean, this would entail also for my story jumping back to the present. But
it's the second part that's bad. As I say, you want to go into the future 2,000 years and see what the weaponry's like. Find one of these people who freezes people, right? And is actually pretty good at thawing them out as well. That's the hard part.
Right.
You can probably pay them and they'll give it a shot, right? They might be able to put you in stasis and thaw you out in 2,000 years, and you can look around and see what the weapons manufacturing industry has been up to. That's within the realm of possibility for sure. That's physically possible.
I mean, you're right, Robinson, that, it might be that, maybe like after the podcast, you go and you've got a closet, and the closet is actually a mouth, a wormhole mouth, and it ejects you at some point really far for in the 2,000 years in my future. But in a sense, it still is sort of, as Tim is saying, because it just means that space-time is weird and it's got a kind of wormhole to it. But in some sense, it's still the twin paradox happening.